In this tutorial, we are going to solve questions on atomic structure and periodicity. Okay, so this is story sheet 4, you last. Then we have a first question there, which is saying, what is the wavelength of light with a frequency of 5.89 times 10 to the power 5 hertz. Okay, so hertz are the same as per second, isn't it? And we know that wavelength is given by speed of light donated by letter C divided by frequency. Okay, so being given the frequency and we know our speed of light from our literature, which is 3.0 times 10 to the power 8 meters per second, divided by the frequency, which we've been given there, 5.89 times 10 to the power 5 per second. Okay, so we're going to put it there. Okay, then we divide. Okay, so when we divide our 3.0 times 10 to the power 8 by 5.89 times 10 to the power 5, we are going to get our final wavelength to be equal to 5.09 times 10 to the power 2 meters. Okay, so this and this will go, the seconds and the seconds will go, meaning we remain with meters as our final units there. Okay, so we can go to the second one, saying a light wave has a frequency of 5.00 times 10 to the power 14 hertz. Okay, calculate the wavelength in nanometers. Okay, so we are still calculating the wavelength. Wavelength is given by speed of light divided by frequency, isn't it? Okay, so we have the speed of light from our literature is 3.0 times 10 to the power 8 meters per second. Okay, divided by the frequency that we've been given is 5.00 times 10 to the power 14 hertz, which is the same as per second there. Okay, so that the seconds and the seconds will go, will remain with our final units to be in meters, right? Then there we divide 3.0 times 10 to the power 8 by 5.00 times 10 to the power 14 there. Okay, so we are going to find our answer in meters to be 6.0 times 10 to the power negative 7 meters. Okay, so now this answer is in meters. Okay, now the question is asking us to find the wavelength in nanometer. Okay, so what do? So we get our answer there, which is 6.0 times 10 to the power negative 7 meters. Okay, we need to convert it to nanometers. So how do we convert meters to nanometers? We're going to multiply with the conversion factor, and we know that 1 nanometer is given by 10 to the power negative 9 meters, so that the meters and the meters will go there, then we'll remain with the nanometers as our units there, our final units. Okay, so therefore the wavelength is going to be equal to, so we get our 6.0 times 10 to the power negative 7 divided by 10 to the power negative 9. Okay, then we are going to get our final answer to be 600 nanometers there. Okay, yeah, so we can go to the next one, which is the third question there. Okay, saying what frequency of okay, so what frequency of the blue, so what is the frequency of the blue light with the wavelength of 484 nanometers? Okay, so we've been told to find the frequency, we've been given the wavelength there. Okay, so no, wavelength is given by speed of light divided by frequency, so we can easily make frequency subject to the formula there. Okay, so we cross multiply, we have wavelength times frequency is equal to C. We divide both sides by wavelength so that we remain with the frequency as our final unit. So meaning our new formula is frequency is equal to speed of light divided by lambda, which is the wavelength. Okay, so that's our new formula there. Okay, so now from there we can easily calculate frequency, isn't it? So now the speed of light we've been given from our literature is 3.0 times 10 to the power 80 meters per second. divided by the wavelength that we've been given, it's 484 nanometers. Okay, so now here, for you to remain with per second as units, your units, you need to convert, you need to have the same units here on top and down. So you notice that on top we have meters, then down we have nanometers. So you need to convert these nanometers to meters. How do you convert nanometers to meters? You multiply by the conversion factor. Okay, so we know that 10 to the power negative 9 meters is equal to 1 nanometer. That's our conversion factor, isn't it? So that the nanometer and nanometer there will go. So meaning our answer will be 3.0 times 10 to the power 8 meters per second divided by 484 times 10 to the power negative 9 meters. So that the meters and the meters there will go. Therefore, our final frequency is going to be equal to, so we divide our 3.0 times 10 to the power 8 by 484 times 10 to the power negative 9. Okay, so when you divide there, we're going to get our frequency to be 6.20 times 10 to the power 14 hertz. Okay, so the second is the same as hertz, isn't it? Okay, so that's our final frequency there. Okay, we go to the next one, which is question number 3 there. We'll go to question number 4. We donated number 3. It's question number 4 there. Okay, so it's saying, what is the energy of a single photon of light? Okay, with a frequency of 6.0 times 10 to the power 14 hertz. Okay, so we are looking for energy of a photon. Okay, so energy of a photon is given by HF. Okay, so H is the Planck's constant. Okay, so H is the Planck's constant. Then we can calculate our F there, which we've been given the frequency there, which is 6.0 times 10 to the power 14. Okay, so we can easily calculate our energy there, isn't it? So we've been given the Planck's constant H. This is the Planck's constant. Planck's constant. Okay. So H is a Planck's constant. So Planck's constant is 6.626 times 10 to the power negative 34. This is in joules second. Those are the units for the Planck's constant. Okay. Then we multiply by the frequency, which is 6.0 times 10 to the power 14. This is per second, isn't it? Hertz the same as per second. Okay, so that the seconds and the seconds will go. Then we can multiply our 6.626 times 10 to the power negative 4 by 6.0 times 10 to the power 14 to get our final energy, which is 3.98 times 10 to the power negative 19 joules. Okay, so that's our final energy there. Okay, so we go to the next one, which is the question number 4. It's question number 5 in that case. Okay, the final one there. Okay, so you're being told how much energy is carried by 1 mole. So we are looking for the energy that is carried by 1 mole. Okay, of a photon with a wavelength 400 nanometer. Okay, so you know that energy of a photon is given by Hc. This is a Planck's constant. Planck's constant. Okay, divided by the wavelength. Okay, so we know the Planck's constant, that's 6.626 times 10 to the power negative 34. Okay, so this is joules second, multiplied by the speed of light, which is 3.0 times 10 to the power 8 meters per second, right? Okay, now we divide this with the wavelength that we've been given. Okay, so the wavelength is 400 nanometer. Okay, nanometer there. Okay, so for energy, here we know that the seconds and the seconds will cancel there, right? So we have meters there. So we need to get rid of the meters as well, so that we remain with the joules as a units for energy there. So how are we going to cancel the meters, the units for the length there? So we are supposed to have these units to be the same, isn't it? So we need to convert this to meters, or we can convert this to nanometers. But convert this to meters by multiplying with the conversion factor. So I know that 10 to the power negative 9 meters is giving me 1 nanometer, right? So that there and there it goes. Okay, so means that I can have my 6 point, okay, so I can have 6.26, okay, 6.6 26 times 10 to the power negative 34. So there I've just remained with joules, okay, multiplied by 3.0 times 10 to the power 8. Okay, now divided by, meaning my, I have 400, okay, times 10 to the power negative 9 meters. Okay, that's my new wavelength there. Okay, so I multiply my 6.626 by times 10 to the power negative 34 by 3.0 times 10 to the power 8. Then I divide by 400 times 10 to the power negative 9. I'm going to get my answer to be 4.97 times 10 to the power negative 19 joules. Okay, so this is my energy. Now, this energy is for 1 photon. Okay, so this is energy for 1 photon. This is the energy of a photon. Now, we are looking for the energy carried by one more of these photons, isn't it? Okay, and we know that one more of a photon is giving us the Avogadro's constant, isn't it? So for us to find one more of a photon, it means that we need to multiply this with the Avogadro's constant. Okay, so there we get 4.97 times 10 to the power negative 19 joules, multiplying it with the Avogadro's constant, which is 6.022 times 10 to the power 23, so that I get my energy to be equal to, okay, so there when I multiply my 4.97 times 10 to the power negative 19 by 6.022 times 10 to the power 23, I'm getting my energy to be 2.99 times 10 to the power 5 joules per watt per mole. Okay, so that's what I'm getting there as my final energy. Okay, so now for the full video solution for this story sheet, you can find them on the website. Let me just show you how you can access our website. Okay, so you can, this is the entire story sheet. This is a full story sheet for UNLAS. So if you want the full video solution for this story sheet, you can access them on the website. So you go on your browser, you search Discrete Learning Institute. If you are using an Android phone, you can download our app on Play Store. Just search Discrete Learning Institute, you will find the app there. Okay, so when you open our website, if you are enrolled, you are going to find the folder written chemistry. Okay, so if you are not enrolled, you can enroll there. You can register. Once you register, you should be able to see something when you open the folder for chemistry. You'll be able to see something like this. Okay, then you go where it's written general chemistry. Okay, so when you open general chemistry there will be these folders. If you want the tutorial sheet, you can go in that folder written tutorial sheets and assessment. You can open there. Okay, once you open, you are going to find these folders for different universities. So if you are at UNLAS, you can open for UNLAS there. Okay. Yeah, so this first semester and second semester, you go for first semester. Once you open for first semester, there are these intakes. Now you go for 2026 January intake for the full solution for that theory sheet. Okay, so now once you open that folder, you're going to see this theory sheet. So you have theory sheet 1, they are there. The full video solution for theory sheet 1 is there. For theory sheet 2, the full video solutions are there as well. Even theory sheet 3. Then also for this theory sheet, which is theory sheet 4, you find the video solution in that folder written theory sheet 4A, atomic structure there. That's what we have. Okay, so you can also access the tests and exam past papers. So you go in the folder written past papers, past quizzes, tests, and exams. Okay, so you can open there. Once you open, it will take you to these folders. You go to your university, which is UNLAS there. Okay, once you open, you're going to find 2 semesters. You go for first semester, you open there. Okay, then you're going to find this folder written video solutions. You can go, if you want video solution, you can go in that folder. You open, then you're going to see these folders. There's 2024, 2023, 2025. So if you want the past papers for last year, 2025, the semester exams, you can open in that folder. You are going to find the videos for mid-semester exam for both intakes. Okay, so you open there, you're going to find the full video solution for both January and July intake. So the full the video solutions are there as well. So you can download the video and watch offline, or you can be watching online if you want. Okay, so thank you so much for being with us.